No, thank you so much. I'm so happy to finish my working day with that impressive meeting again. So EPIC is always a pleasure. Not only online meetings, also in-person meetings. So it's every time I feel really honored to be part of those meetings. And yes, thank you to have the chance to talk a little bit about what happened in the last, let's say, a year. We had a nice meeting in Stuttgart together with EPIC, which was really impressive. Yes, and to be honest, the last times have not been that promising. So there are some numbers. I put on some numbers which were really promising from the year 2020. Where everybody thought that e-mobility, the battery, in the battery context, we all as photonics community play a major role. I'm pretty sure we still can, but everything has slowed down. Everything has slowed down. There is not that high speed again, or still, but which does not has any let's say major impact on what photonics can do for the electric production chain, for the battery production chain. If we are talking about e-mobility, I just put on 2 slides because it's some private issue. This is the topic where my youngest son is working on these days. He's with Kion, with Still, or with Linde. So he's working on forklifters, and he's working in the department of batteries. So it's quite impressive what those companies already did in providing power systems which are not based on fossil energies. So you see here they have already deployed possibilities to have energy sources, not only battery style, so it's hybrid, it's lead, it's the classic lithium iron battery, which can be plugged in those forklifters easily because they have the same connectors, the same weight, which is important. Weight is important, which is different to cars more or less, but weight is important in those forklifters. And you see they built 12,000 batteries of that size per year. So it's always a huge market. So it's not necessarily just the cars we are using every day. Nevertheless, the cars we are using every day, they have the applications. They have the applications. I'm pretty sure that I'm not the first one today who says that those applications and the modules and the parts behind are really, really expensive. Which means we must take care of the resulting quality of our laser welding applications, or of, let's say, of the laser material processing applications.
Markus,
Yes?
sorry for interrupting. Are you already sharing the presentation? Because we don't see the screen.
You don't see the screen?
No.
I don't think. Okay. 1 second. I said so.
Now it's working, yes.
Okay, sorry for that.
No problem.
So you're fine now? Okay.
Yep.
Okay. That was before. So forklifters do have an impact on e-mobility, which is not the car. So whenever you are interested into that, just approach my son, who is working on that topic. Nevertheless, we have cars. We are working on stuff which is really, really expensive nowadays. If you think about the final module, nevertheless, if it's the battery, the packaging, if it's the hairpin and the resulting element. So everything is much more expensive as the final product than it has been in the combustion engine times. But we see the laser as a tool of choice. This is just one of those applications where we are comparing the laser to other joining strategies, resistant welding, mechanical connections, or wire bonding. And you see that in most of the fields, the laser has a very, very impressive advantage against all those others. And as the laser sources are getting cheaper and cheaper, the advantages pay off more and more and more. The same is if we talk about the materials. If we talk about copper, if we definitely talk about steel. So steel and lasers is it's winning a team, definitely. And I'm pretty sure Andreas Heider will talk about that in his presentation. Nevertheless, we need to take care about something which we haven't taken care about, let's say, 10 years ago. And this is the point where we apply the photons. And we have the freedom these days. We have the freedom these days to bring the photons to the right point for the specific application, for the specific material. So it's not necessarily just top hat or Gaussian beam, which has it been, let's say, 10, 15, and the years before. We now have the freedom to work on that. And the freedom to work on that is to use beam shaping. And there are a lot of choices on the market with respect to beam shaping based in quotation marks on optical elements, but also there is combiner technology, fiber manipulation technology, and coherent beam combining, which is the most impressive stuff and for sure the most expensive stuff these days, we have to admit. Nevertheless, beam shaping is crucial, and it really helps in many, many applications, and also in the applications we are addressing in e-mobility, to increase the quality of the final weld of the final product. We have done so with our ScanMaster, which is a combination of many Precitec knowledge, from cutting to sensor technology to welding, which is all part of that ScanMaster. But the ScanMaster also includes beam shaping technology. And we have partnered with K-Labs on that, because we have seen that technology is for us the most promising one, because it can be easily integrated into our beam path, and it can easily change from the old-fashioned just Gaussian or top hat beam profile to a better profile for the specific application, which means for us it's just an add-on module which is in between the collimator and the processing head, in order to change the intensity distribution and in order to increase speed, reduce the spatter formation. So there's many, many benefits for us to include those elements, to include beam shaping in our beam path. For sure, and this is what Antonio already said, for sure we are also taking care about the quality with means of sensor technology. So there has always been, and there will always be, Precitec products with sensors. So no Precitec processing head will leave the company without at least one sensor. And in welding, it's most probably photodiode sensors these days. And the old-fashioned way of applying photodiode sensors was to get the fingerprint of a process, to calculate envelopes for the upper and lower interaction limits, and to say the process is good or bad. So we have taken the chance with customers to name one of the customers is Audi. We have taken the chance to go one step further. We have now worked on the possibility to derive specific physical information out of that process light. Customers like Audi, like others, approached us and they said, so we need more information. Just red, green is not enough. We need information about, for example, the strength of the weld or the electrical resistance or the depth. Okay, let's say depth we had in our pockets already by applying OCT. OCT is one of those sensor technologies which was more or less pioneered by Precitec in order to measure weld depths during processing. But this is just one of the physical information customers were talking about. If we talk about other physical information, as I said, like strength or the electrical resistance, we need to go one step further. And this is AI. We need to apply AI. We have increased our AI knowledge at Precitec by setting up a department at the University of Karlsruhe, which is the Precitec incubator. These are data scientists. They only know data science. They only know data processing. And they worked on applying specific deep learning algorithms on our time series data. And in the end, we had the other way around. In the end, we had those information, those mission functions where we could bring measurement strengths to predicted strengths in at least 2 applications. The one on the left is a high power application, 3.8 kilowatt aluminum welding. The one on the right is micro applications, nanosecond lasers, dissimilar materials. But in the end, it's more or less for the artificial intelligence approach, it's the same. We applied approach based on long-term short memory, LSTM, which is, as you see, one of the possibilities out of many, many in the deep learning portfolio. LSTM is maybe known from the one or the other who is listening as the deep learning algorithm behind Siri or behind Alexa. They also use LSTM. And it's one of the specific ways of working with time series data. And our photodiode signals, those are time series data. It's a lot of data, I have to admit, and it's a high frequency of data, but the LSTM is one of those which is the most promising. And in the end, our approach is to be able to work with AI algorithms on laser welding applications, to apply AI algorithms. So this is one of the applications where we're working on now. So it's different to the 2 which I showed you before. This here is the battery contacting, and for sure the physical value here, which is important, is the electrical resistance. You see, just for exemplarity purposes, we have shown here a zigzag welding. So customers use different strategies for welding these contacts. Nevertheless, the idea is we get the time series data, we apply AI, and in the end, we derive the electrical resistance directly in microohms out of the emission data, which is coming from the process. And you see that we can calculate good or bad resistance, and together with the customer, we have taken the chance to apply a repair weld next to the original weld with the hope that we then can bring the electrical resistance to the desired value. And okay, we have one customer who is doing that right now. It's just starting. So for us, it's also new technology. new experiences, but we are hoping that we convince more than that one customer on the profitability of applying AI in those applications. And maybe we can generate some kind of cloud, customer cloud, Precitec cloud, whatever the name is, that we can also connect information over the global planet. Okay, we are a small company, but nevertheless, we are globally active. And maybe we can also use that chance in order to increase the knowledge and to teach and learn our AI models just over the globe. So yes, these are the messages I hope you take home. It's an extra mile, and we go the extra mile. The extra mile is definitely with respect to AI. We can check mark that we have successfully started beam shaping inclusion in our processing devices. We can check mark that we apply AI. Nevertheless, every AI application we do right now is a whole lot of work, because the training, to get the training data, is really expensive and time consuming. Nevertheless, if we are able to convince more customers, maybe we have the chance to continue and working on that and make people happy. The typical epic question in the end, what can you do for them and what can they do for you? So we can provide knowledge on the applicability of AI methods in combination with laser processes. And we need customers who are willing to provide their data in order to make our work easier, in order to speed up the AI applicability in lasers. Customers just need to be open for the new technologies, and if they are open, we increase the speed in that innovation. Thank you so much for your attention.